Very good morning. I am Dr. P. Usharani, Professor Triple E Department, RMD Engineering College. I am going to brief about the topic of functional block diagram of measurement system. Just the subject transducer engineering. Okay. First we will see what is sensor and what is transducer. Sensor is a device, okay, which converts any physical quantity. For example, we can say temperature, speed, pressure, etc., which will be detected by this sensor and which are converted into an output quantity. Okay, both are non-electrical quantity here. That's the major difference between the sensor. What it does, it will convert your input to output. Both are in non-electrical form. Okay, for example, we can say temperature and humidity sensor, gas sensor, ultrasonic sensor, CMOS, PIR sensor, fire detector sensor, like this. It's only detect, okay, the non-electrical quantity to non-electrical quantity only in analogous form. For example, I can say I can I can use a pressure sensor for measurement of pressure. So I can take some meters away. Okay, I'm going to use a pressure sensor here. I can take any parameter of electrical. So pressure, if I use which is proportional to voltage, means there is a problem. I cannot use pressure in terms of voltage because the voltage is not constant throughout long distance. Due to the voltage drop, we are not utilizing the voltage as a parameter. Now we can use pressure in terms of current, which is proportional to current we can take. Okay, so due to the voltage drop only, we are not utilizing here, which is not voltage drop occurs at any point. Okay, that's the major drawback why we are not choosing voltage. Now we can use pressure is proportional to directly current. We can measure it, okay, in terms of 4 milliamps. The standard value is 4 milliamps to 20 milliamps. What's the meaning here is the lowest pressure value as 4 milliamps, the highest pressure value as 20 milliamps. You should take care of the impedance value. So for example only I have explained the pressure sensor in the values of 4 milliamps to 20 milliamps. Next is transducer. What is a transducer? What it does is it converts one form of energy to another form. That is, input as non-electrical quantity, which is converted to electrical quantity. Not only electrical quantity, it may convert thermal, mechanical, optical, electromagnetic. Okay, so here the input as non-electrical, the output as electrical quantity, but they are in analogous form only. Okay, for example, we can say RTD, thermocouple, potentiometer, piezoelectric crystal, strain gauge, LVDT. So the major difference between sensor and transducer is sensor detect the input quantity, okay, the measurement, which is non-electrical form, which converts into non-electrical form. Okay, temperature, pressure, like that we can convert that into non-electrical quantity only. If you use a transduction element, that is the transducer, what it does is it converts one form of energy to, that is a physical quantity, non-electrical quantity to electrical quantity. Okay, not only electrical, we can say thermal, mechanical, optical. So I have explained what it does. Okay, for example, I can say microphone and loudspeaker, which is connected. In between, I have fixed one amplifier. Okay, so if I take the microphone, the sound energy is converted to electrical energy in the loudspeaker output, or you can say the loudspeaker input as electrical energy, which may be converted to sound energy. Okay, so we can say the example of this as transducer. So the functional block diagram of the measurement system, I have shown the block diagram. First part I have explained the primary sensing element, which consists of sensor and transducer. So the input, the measurement, which is a non-electrical quantity, is converted to electrical quantity here. Okay, both are in analogous form only. So the analogous form, which for the usefulness of the applicant side, we need to convert. For that, we are going for conversion. So variable conversion element is used here. Analog to digital converter we are choosing. So which converts the analog input is converted to digital output. Okay, that is the function of variable conversion element using ADC. Next one, variable manipulation element. Here for variable manipulation element, what it does, okay, you have to manipulate only in the numerical value we are going to manipulate. Okay, in that it does two functions. One is linear manipulation, another one non-linear manipulation. If you consider linear manipulation means we can do the functions of addition, subtraction, integration, differentiation, amplification and attenuation. These are linear functions. Okay. If you go for non-linear manipulation, we have to do modulation, deduction, sampling, filtering and chopping as well as clipping. Okay, these are the non-linear manipulation. So for that we are using manipulation element. In general, the variable conversion element and the variable manipulation element is named as conditioning elements. Okay, which conversion element converts analog to digital form using ADC. Manipulation element manipulates the data, which is both in linear as well as non-linear. Linear, I have explained few functions: addition, subtraction, integration, differentiation, attenuation, amplification. Non-linear, I have explained deduction, modulation, sampling, filtering, as well as clipping, clamping, okay, chopping, we can say. Next is the output is converted to goes to transmission element. Okay, the data must be transmitted. So for transmission we have two things we are using. One is wired transmission, another one type wireless transmission. Okay, which one is better? If you take a wired one is better, reliable and faster. Okay, wired transmission, data transmission. For wireless we are using LAN cable, Wi-Fi modem, like that. Okay, but wired and wireless transmission we are using, data must be converted and the data must be stored and useful for the presentation element. Okay, which may go to storage element and data presentation element. For that presentation, which will be useful for monitoring, control and analysis. Okay, if you take a monitoring means we can three functions I am saying. One is monitoring, other one analysis, another one controlling. You know, controller means you can use microcontroller, microprocessor, the basic thing, or you can use computer, the advanced controllers, you can say. And monitoring means the visual display devices. For example, I can say ammeter, voltmeter, wattmeter. Okay, that is your visual display devices. Third one I have mentioned analysis. For that you have to store it. That is the record it and then you have to display. For that example we can say TV, camera, okay, printer, everything. So on the whole block diagram represent the functional block diagram of measurement system, which consists of primary sensing element, variable conversion element, manipulation element, data transmission element, and data storage element, and finally data presentation element. Okay, thank you.